In this video, we are going to look at outcome B1, part 2, which is how to take the square root of a function. So there's the biggest distinguishing point between this lesson and the last lesson is that in the last lesson, we were looking at how to do transformations on the graph of the square root of x, or radical graphs. And we were taking that graph, which remember looks like this, and we were transforming it. The difference in this lesson is that now we're talking about using square roots as a transformation themselves. So for example, if we want to take the square root of a function of f of x, essentially what we're going to be doing is we're going to be taking the square root of each element of the range, and remember the range is all the y values. So we're going to take our function, we're going to look at each y value and take its square root, and that will give us our new function. So you can think of it as the value of xy is going to become x square root of y. So the x values are staying the same and the y values are being square rooted. So just remember a few things. When we're thinking about our domain and range, you cannot take the square root of a negative number. So if you have any y values that are negative, they aren't going to exist after you've done this transformation. Those y values were negative, so when I take the square root, that square root is not a real number. So the range of this square root graph or root graph is basically only going to exist where those y values are positive or 0 or greater. Okay, so for example, if we look at example 1, I've given you f of x. So here's f of x. It's a straight line. And in that graph, you've got a few pairs of points. You've got the point -6, 2, -4.51, -4, 0.75, and -3, 0. Those are the points that I've picked off of this line. Now you might be wondering why I've picked some of these decimals, and the reason for that is because I want to show you what happens when we have these differing y values. But essentially what we're going to do is we're going to take these points and we're going to transform them, and we're going to leave the x value by itself and turn the y value into the square root of y. So to do that, we're going to take the square root of each of these y values. And you'll notice a few things happen. For this point 6, 2, the square root of 2 is 1.4. So this just moves down. Remember, the x values aren't changing. For the value -4.5, 1, which is right on this line, when we take the square root of 1, the result is still 1. So that point is invariant, meaning it's staying in the exact same place. When we take the square root of 1, we get 1. So that point hasn't moved. If we look at, and I chose a point -4, 0.75, I just wanted to choose a point that was between here. So this is the one that I chose. This point, when I take the square root of 0.75, you'll notice the answer is 0.9. So this 0.75 actually goes above the original graph. So whereas all of my values that were greater than 1, when I take their square root, they go below the original graph. The values that are less than 1, when I take their square root, that number is actually larger. And then again, when I have a y value of 0, so here the 0.30, and I take its square root stays the same. So it's another invariant point. What essentially I'm trying to show you on this graph is that in these radical graphs, you're generally going to have two invariant points. Those invariant points are going to be the points where y equals 0 and y equals 1. Those are not going to change. For any y values between 0 and 1, when you draw the square root graph, the graph is going to go above the original function. And once you get past y equals 1, the graph is going to fall below the original function. In this case, all of these y values down below are all negative, so I cannot take their square root. Their square root is not a real number. So none of these points down here exist on my new graph. So this function here would be the square root of f of x. Do the same thing for part B, where I have y equals 0. The axis is a little bit hard to see here, but this is the axis. So where y equals 0, I have an invariant point, and wherever y equals 1, I have another invariant point. And you'll notice that between 0 and 1, I've gone slightly above the original function. These are y values of 0.1, 0.2, 0.3, 0.4, etc. And when you do that square root, the value is going to be greater. So these go slightly above. And then I chose the point where y equals, you've got here where y equals 3, for example. When you take the square root of 3, do that quickly, you get 1.7. So this y value would be at 1.7 approximately. And you can go from there. You'll see here I've got a point marked. That's the point where y equaled 4. So its square root is 2. So I put that point there. You could also use this point where y was 9, and it would now equal 3. And you could extend this even further. You'll notice for my domain and range of both of these graphs, the range is always 0 to infinity. And that's because 0 is the lowest y value. And my range goes from negative infinity up to whatever my x-intercept is. Whatever that x value is, where y equals 0, is going to be the limit on your domain. So in this one, it's -3, and in this one, it's -2. Now, those two functions were both linear functions. So when I take the square root of linear functions, I get these shapes that look very much like the radical graphs that we were looking at in the last lesson. But I also need to know how to do this, excuse me, on parabolas. And the idea is still very much the same. When you have a graph, in this case a parabola, it can either be opening downward or opening upward. If it's opening downward, it will always have this shape, where the parabola just sort of flattens out a little bit. If it opens upward, you're going to have this shape where your new function extends out in two pieces. So let's look at y. In this graph, I always like to find my nice perfect square numbers. So if you look up here, I've got a y value of 9. Remember, all I really care about is my y values. Those are the ones that I'm going to take the square root of. So a y value of 9, when I take the square root, is going to move right down and be a y value of 3. Notice the x value doesn't change. The y values of 4 are here and here, and those are going to become 2 and 2. Just try and line up your x value as closely as you can. And then my y values of 1, which are here and here on the original function, will stay the same, and y values of 0 will also stay the same. And between 0 and 1, I know that the function goes just slightly above the original function. So you'll see I've got a slight little bump in the graph. It's hard to see. If you open the PDF on this one, it's a little easier to see. So between 0 and 1, I go slightly above, and then from 1 all the way through here till I get to 1 again, my graph is below the original function, and then it goes back
to all dance
to 0.
students for
Sorry.
this Friday in this student block. Dance class will be canceled again this Friday due to the school in-service. Again, for all students, there is no school this Friday. Thank you.
Okay, so between y equals 1 and y equals 1, this graph is below, and then I've got this slight little bump. Again, when you look at your domain and range, when it comes to parabolas, these are a little bit more varied. But our domain goes from -2 to 4, and our range goes again from 0, and in this case it has a maximum of 3. That's because it opens downward. In question B, this parabola opens upward. So any of these y values on the bottom of the parabola that were negative are not going to exist on our new transformed graph. But again, I can take those perfect squares. So for example, I've got y values of 0 that are invariant and y values of 1 that are invariant. Between 0 and 1, I'm going to go slightly above my original graph. And then I've got y values of 4, which will become 2, and 4, which becomes 2, so I can trace my graph out to extend both to the left and right. So in this case, my domain goes from -infinity up to -4, and then there's a gap, and then it goes from 0 to infinity. And my range goes from 0 to infinity as well. Now the last graphs in example 3 here are actually cubic functions, but they work the exact same way. First thing to remember is that any negative y values are not going to exist when I take the the square root of these graphs. So here, where my y values are negative, I have no new y values. But here, I've got 3 y values of 0. Those stay the same. In between here, and it's really hard to see, I'm going to zoom in the video just a little bit. You have some y values here that are really quite small. You'll see that I've marked one here at -0.5. The y value is 0.325. When you take the square root of that, you get 0.57. So you'll notice that my graph in between these 2 points here goes slightly above the original. So that's one piece of this graph. And then over here, again, I've got a y value of 1. And in between, there's some y values that are between 0 and 1. So the graph goes above, and then it's going to continue outward. Here, you could use this y value of 4 to mark your 2 there. So this graph is going to go out from 0 through 1, and then it's going to be below the original function. So this graph goes from -1 to 0, and then it has a little gap in it, and then it goes from 1 to infinity. And the range, again, goes 0 to infinity. For question B, it's very similar, but this graph, you'll notice, doesn't have that gap like the first one did. Here, we've got some negative y values on the very left side of this, but then our graph goes just slightly above. So here, I've got a y value of 0.125. When I take that square root, it's 0.35, so slightly above the function. I then have an invariant point where y equals 0, an invariant point where y equals 1, and between 0 and 1, my graph goes slightly above the function, and then it's going to fall underneath. In this case, I don't have any perfect squares to work with, but the square root of 2 is, I should know that one, is 1.4. So this one should actually be a little bit steeper. This point should have gone up here. That's what happens when you sketch. This is tricky to draw. It should be up there. It's just a sketch, so if you have it falling below, it's not a huge deal. So that wraps up lesson B1 part 2 on square root functions. Try out some of the practice questions and let me know if you have any questions about anything.